Hello guys, how are you today? So today I'll be explaining chapter 4 in chemistry, so it's a chapter 4 summary. And for the chemistry periodics, we have chapter 4, only the sections in chapter 4, we only have 4.1, 4.2, 4.6, 4.7, and 4.8. Okay, we don't have all of chapter 4, just these sections. Then chapter 5, we have 5.1 and 5.2. Then for the topics, we have halogens, nitrogen, and sulfur. So the title of this is Chapter 4 Summary. Of course, it's gonna be like a brief explanation. If you want to go into details, you can open the book or even the notes. Alright, so we start off the chapter by talking about something that we've discussed before, which is the halides. Now, whenever we are discussing the halides, we usually mean it is at room temperature, or RTP. RTP means room temperature. Now, do you remember this order? It was F is stronger than Cl, is stronger than Br, is stronger than I. If you cannot memorize it like this, then you can easily just say Fickelbrie, okay? And then you will have it. So, this is stronger than this is stronger than this, and this is stronger than this. But what exactly does stronger mean? Let us take two examples. Let us take Br2 plus NaCl, okay? And then Cl2 plus LiBr. These are just two random examples. Now, following the order, we know that definitely Cl is stronger than Br. So what's going to happen is something called displacement. In this case, you have Br2 plus NaCl. So is the Br2 going to displace the ion of Cl? Definitely not, because Br is not stronger than Cl. However, Cl2 can displace the ion of Br. So here, very simply, there is no reaction, Nr, okay? Whereas here there is gonna be a reaction. So if we're gonna write the reaction, basically Cl and Br are gonna switch. So it will become Br2 plus LiCl. Alright, so for the halides, just memorize in order Fickelbrie. And for example, F can displace Cl, Br, and I. Cl can displace Br and I. And Br can only displace I. That means I is the weakest halide and cannot displace anything. Alright, so we move on to our next topic, which is oxidation. So if you want, I'm going to give each one of them a section. So this is section 4.1. Alright, moving on to section 4.2. In section 4.2, we talk about two things, which is oxidation, okay, and I will go down a bit, reduction. If you add oxidation and reduction together, you are going to get something called redox. Oxidation is a chemical reaction by itself. Reduction is a chemical reaction by itself. Together, if they happen in the same compound, or even possibly the same atoms, okay, then we call this a redox equation. Now, before we define what redox means, let us know what is the meaning of oxidation and what is the meaning of reduction. Actually, this one is gonna be a bit long because oxidation has 3 different meanings and reduction also has 3 different meanings. So, starting off with the first meaning of oxidation. This is the most basic meaning from before, like really long times. They used to think oxidation meant the addition, my bad, sorry for the bad handwriting, the addition of oxygen. And likewise, they thought reduction meant the removal of oxygen. So what we can notice here is that oxidation and reduction are complete opposite reactions. So if this one is addition, this one is removal. Okay, now we are gonna see more ways in how they are opposite. Okay, so the next meaning of oxidation means the loss of electrons. So if an atom loses its electrons, we say this is oxidation. Whereas reduction is the gain of electrons. So that means if an atom gains electrons, that means the reduction has happened. So in other terms, loss of electrons means that the charge on top becomes positive, okay? Or not necessarily positive, just it becomes a bigger number. Then we say this is oxidation. However, if we gain electrons and the charge becomes a smaller number like, okay, you have +1, this is a big number, but then what's smaller than +1? -3 is definitely smaller than +1. This is what is meant by smaller. So if it gains electrons and it becomes smaller than its original charge, then we say this is reduction, okay? Now the last and final one, which we will discuss also in 4.3, is based on oxidation number. So oxidation could possibly mean an increase in oxidation number, ON, whereas reduction means a decrease in oxidation number, or ON. All right? Now, something additional we must know is that the element, or not necessarily the element, anything that undergoes oxidation in a reaction. So, for example, let us say Na plus Cl gives us NaCl. Na, its original charge was 0. Cl, its original charge was also 0. However, in the compound, Na gets a charge of +1 and Cl gets a charge of -1. So what happened to the Na was that it lost electrons, so that means Na underwent oxidation. Okay? What happened to the Cl was that it gained electrons, that means it went under reduction. In other terms, okay, their oxidation number changed. So Na had an oxidation number of 0, it became +1. Cl had an oxidation number of 0, it became -1. So we cannot really use this property over here, the removal and addition of oxygen. It was just something they thought of back in the days. But now, these two, the loss of electrons and oxidation number, this is the more necessary things when trying to understand what is oxidation and what is reduction. Now, if you notice, we have oxidation and reduction in the same equation. That means that this equation over here is called a redox equation. Now, before I leave this page, I need to say something. Or not I need to say something, I will say something. And this is something we have to remember it, okay? It's very important. The thing that undergoes oxidation, so take our previous example, what underwent oxidation? The Na underwent oxidation. So the thing that undergoes oxidation, we call it the reducing agent, okay? Or reductant, however you want to say. But I prefer to say reducing agent. However, the thing that undergoes reduction, which was Cl in the previous example, we call this the oxidizing agent, or the oxidant, however you want to say it. Now, what does reducing agent mean and what does oxidizing agent mean? The thing that undergoes oxidation, okay, for this is only true in the case of redox, okay? So if there's oxidation by itself, it won't happen. If it's reduction by itself, it's not gonna happen either. So these terms are only true if we are talking about a redox equation, okay? So the thing that undergoes oxidation is called the reducing agent because it will trigger the other element or compound or whatever to undergo reduction. All right, and it's the same the other way. The thing that undergoes reduction is called the oxidizing agent because it will trigger the other element or compound or whatever to go under or to undergo oxidation. All right. Now I'm gonna add a page, and I need to discuss something before we move on to the next section, which is 4.6, half reactions. What are half reactions and how do we use them? Now the most important thing that we need to know is that half reactions, they include only the element, okay, the element's ion, so their ion, and electrons. Alright, now why do we need this? This can help us determine better if it's an oxidation reaction or a reduction reaction, or if it is a redox reaction. It helps us to form the equation. So let's take back into consideration the NaCl. We had Na plus Cl became NaCl. We said here it was 0, here it was 0, here it became +1, and here it became -1. Okay, so if we write the half reaction of Na, it's gonna be Na, it gave us Na plus, because in NaCl it's an ionic compound, we have Na plus and Cl minus. It gave us Na plus in addition to 1 electron. So this is the half reaction of Na. Let us do the half reaction of Cl. Cl, we added to it an electron because it gained an electron, so +1 electron is gonna give us Cl minus. Now, if you try to balance this one, okay, if you try to put it in one equation, you are just gonna get the original equation. Although this is not the same for all cases, you have to pay attention if it's the same for all cases. So in this case, it's gonna be Na plus Cl plus 1e minus gives us Na plus 1e minus plus Cl minus. So they will cancel each other because they are on opposite sides. So if you move it to the other side, this is basic math, it becomes minus, so they will cancel each other out, okay? And that leaves us with Na plus Cl gives us Na plus Cl minus, or Na plus Cl gives us NaCl. Now this is it for 4.2. We move on to 4.6. Now here in section 4.6, we are going to discuss more about the oxidation number, and we're going to dive deeper into it. So what is ON, or oxidation number? You write it like this. What is oxidation number? It is, in very brief terms, a fictitious or imaginary charge that is assigned to the atom when pairs of electrons shared between it and other atoms are counted according to certain rules. So instead of writing all of this, I'm gonna make it shorter and in a quick summary. In other terms, oxidation number means an imaginary number given to an atom in its compound. And of course this happens only if charge is shared. So oxidation number is an imaginary number given to an atom in its compound, and this happens only if the charge is shared. So I'm gonna have a table of oxidation number. Okay, I'm gonna write it here. So down is the table of oxidation number. Okay, how does it work? We're gonna draw a line like this. It's not a proper line, but it works. Here we are gonna have the atom, or whatever it is, or compound, okay? And then here we are gonna have its oxidation number. So we start off with elementary atoms. Elementary atoms means that it is in its elemental state. So elementary atom, an example, for example, is Na Cl, Fe, anything like this that doesn't have a charge, we call it an elementary atom, its oxidation number is always 0. Moving on, we're going to discuss simple ions. So simple ions, they are NaClFe, but they have charges. So for example, Na plus, S2 minus, these are two examples of simple ions. Now the oxidation number is the charge of the atom. So if we took Na plus as an example, the charge becomes +1. Okay, the charge is +1. Okay, so the oxidation number becomes +1. If we take S2 minus as an example, the charge becomes -2, or it is -2. So then the oxidation number is -2. Then if we continue our table, we start with fluorine. Fluorine by itself, or F, okay, its oxidation number is always -1. Okay, so this is something we have to remember, that the oxidation number of fluorine, F, is always -1. Now, if we're talking about group 1 metals, for example, Li, Na, K, Rb, Cs, Fr, the group 1 metals you can see on the periodic table. So let me just open the periodic table. So this is the periodic table over here. These over here are group 1 metals. Then this over here is group 2. Okay, so we just need to know group 1 is Li, Na, K, Rb, Cs, Fr. And then group 2 is Be, Mg, Ca, Sr, Ba, Ra. Okay, what we also need to know is that here the charges is always +1, and here the charges is always +2. So in other terms, let's take for example Li plus and Mg2 plus. Because they are simple ions, then the oxidation number is gonna be their charge. So here it's gonna be +1, here it's gonna be +2. So going back to our table over here. Okay, so that means group 1 metals have a charge of +1. And in the same way, group 2 metals have a charge of +2. Alright, now we move on to Al. Here is where it gets interesting. So let's open the periodic table again. Come over here. Al over here, like all of these, have a charge of +3. So that means Al 3 plus, Ga 3 plus, and again they are simple ions, so that makes their charge to be +3, +3, or in other terms their oxidation number is +3. So going back to the table, we have Al, its charge is gonna be +3. Now I'm gonna do a different table now because these ones are a bit big. So now we discuss oxygen. Oxygen is a really unique case because it has multiple charges. So oxygen, usually, most of the time, its oxidation number is -2. However, if it is with peroxides, meaning H2O2, then its oxidation number is -1. However, if it is with fluoride, okay, usually in nature it's found as OF2. Now, why is it found as OF2? I'm gonna have a small explanation. It is because F is really strong in nature, so it's always found as F2, okay? And if we're gonna put the compounds together, we know that F2 has a charge of -2. Why? Because F has a charge of -1, or not a charge, an oxidation number of -1. So then F2 will have an oxidation number of -2. So that leaves us with oxygen having an oxidation number of +2. So only in this case, in OF2, does oxygen have an oxidation number of +2. Okay? I'm gonna go up and I will do Cl, Br, and I. These we have to memorize that they have an oxidation number of -1. And now finally we move on to hydrogen. Okay, Hydrogen with nonmetals, okay, it has an oxidation number of +1. However, with metals, it has an oxidation number of -1. So this is the oxidation number table, okay? Hopefully it made it a bit easier. You just need to memorize these, and hopefully it will come easy like this in the exam. So now we move on to something different than oxidation number. Okay, so now we move on to just something different, okay? Something we also need to know is that acid-base reactions are not redox reactions. So acid-base reactions are not redox reactions. So if you see, for example, an acid, let's think of any acid. For example, HCl, in addition to a base, which is NaOH, it will give us what? Water, H2O, plus NaCl. This is not redox, okay? It is just a neutralization reaction. All right, and then we move with something called electrode potentials. So let me open an example, and from the example, I will explain what electrode potentials are. So we have this example over here. Sorry, I had to take a picture because I cannot take screenshot on the ebooks, and the ebooks on my SDP wasn't working either. So I had to do it like this. Anyways, in this question, you see they're asking us, hydrogen ions of acids do not react with all metals. Predict whether the hydrogen ion of the acid reacts with the given metals. Given the following electrode potentials. Now these are electrode potentials. Always they are given to us. Whenever we are dealing with electrode potentials, what we need to know is that we need to order them from the highest electrode potential to the lowest, okay? Now to know if a reaction occurs or not, what we are gonna do is, first thing, let's take this one as an example. Ca plus to H plus. We do something called the gamma trick. You can do it if you want, and if you don't want to do it, you don't have to do it. So we start off with Ca, okay? Then we have 2H plus, okay? And then we need to see, does it work or does it not work? So Ca, we go around 2H plus and we go up. This, we call it a gamma trick. It makes the form of a gamma. If it makes the form of a gamma, which in this case it did, then yes, a reaction will occur. However, if we are gonna go to the next one, Ag plus H plus, and we do the gamma trick, you will see that it does not form the gamma. It's upside down, so no, it does not form a reaction. This is all I'm gonna discuss about electron potentials. If you guys want to dive deeper, of course you can open the book. But this is all that is required from us for the electron potentials. Sorry, not electron potentials, electrode potentials. And that's really great because we just finished 4.6, so now we can move on to 4.7. Okay, 4.7 is very simple. It's not too much thinking. It's more about memorization and understanding. So in 4.7, we are gonna discuss electrolysis. I don't know how to say it. Electrolysis. There we go. Electrolysis. Now, what exactly is electrolysis? If you open the book, you will see it has a big meaning. But in 3 small words, we can define electrolysis. Sorry, I'm gonna struggle to say this because I cannot say it. Anyways, so by 3 small words, we are gonna be able to define electrolysis, which is separation by electricity. So very simply, electrolysis means separation by electricity. Now, I will write the deeper meaning aside because, of course, it's going to be helpful. So you can either define electrolysis by separation by electricity or decomposition of an ionic compound when molten or aqueous by the passage of an electric current. Okay, so you can either define electrolysis by separation by electricity or the composition of an ionic compound when molten or aqueous by the passage of an electric current, which is literally the same thing. So separation, okay, I will underline it in red. Separation means decomposition of an ionic compound when molten or aqueous. By electricity means by the passage of an electric current. So very simply, 3 words can replace this whole paragraph. So now I'm gonna draw a simple electrolyte, electrolytic cell. So simple electrolytic cell. Alright, so the diagram is gonna be a bit small, but we can deal with it. I will do it in blue. Okay, we have this over here, then we have this over here, which is called electrolyte solution. So this liquid is the electrolyte solution. It's the thing that contains the electrolyte. So for example, if we're dealing with aqueous NaCl, then it is the electrolyte solution. Okay? Alright, so I will draw the anode and then the cathode. And I will draw the battery. So this over here is the anode. This over here is the cathode, just for the sake of this explanation. Now, what's going to happen is that the anode is connected to the positive terminal. So it is positively charged, or in other terms, the positive electrode. The cathode is connected to the negative part of the battery, so it's negatively charged, or in other terms, it's the negative electrode. So what's going to happen if we're going to take NaCl as our electrolyte solution? First of all, it's going to split into Na plus and Cl minus. Now, the positive charge of an ion is always called a cation, whereas the negative charge of the ion is always called the anion. So what's going to happen is that I will change to a different color. The anions in the solution are going to go to the anode. So we're going to say these are anions, which are negatively charged. However, the cations are going to go to the cathode. So this is cations, and they are positively charged. Okay, now here is a really important part. What happens at the anode is oxidation. And what happens at the cathode is reduction. So remember, the thing that goes to the anode undergoes oxidation, whereas the thing that goes to the cathode undergoes reduction. And one more thing before we move on to 4.8 is that since we are dealing with charged particles, since we have charged particles, then the electrodes, okay, are usually inert. What does inert mean? It means they do not have a charge. So since we have charged particles, electrodes are usually inert. Most of the time, platinum or graphite, which is carbon. So because we are dealing with charged particles, positive and negative, the electrodes are usually inert, okay? The last section, which is section 4.8. So there are some general rules when we are dealing with electrolysis. Okay, so we're first gonna discuss the cathode, then we are gonna discuss the anode. So going back up, this over here is the cathode. We're gonna discuss about it first. So cathode. Some rules we need to know is that it will either discharge metal or hydrogen. So either discharges metal or hydrogen. Okay, Now there is a list of metals we need to know, so I'm gonna write them. We have Na plus, Mg2 plus, Al3 plus, Zn2 plus, then we have H plus, then Cu2 plus, and Ag plus. So what's gonna happen here is, if we're gonna take it like this, and how I did it, the ones above H, okay, no matter what happens, they don't discharge. Instead, H plus gets discharged. So, for example, if we are dealing with Zn2 plus, okay, and Ag plus in two different electrolyte solutions, what's gonna happen is that at the cathode, the Zn2 plus is gonna go there, but instead what's gonna discharge is H plus. Whereas since Cu2 plus and Ag plus are after H plus, okay, they're not gonna change into H plus, they're just gonna discharge normally. So Ag plus will go to the cathode and it will discharge as Ag plus. So in general, what we need to remember is this form, that Na plus, Mg plus, Al3 plus, and Zn2 plus, they don't discharge. Instead, H plus discharges. Of course, H plus will discharge H plus, okay? And then Cu2 plus and Ag plus are gonna discharge as their normal selves. Now that we finished discussing the cathode, let us discuss the anode. Now there are two things we need to pay attention. Is it concentrated? And are there halides? These two things are really, really important. So if it is concentrated, then what's gonna form? A halide will definitely form. So if we are talking about Cl minus, okay, concentrated Cl minus, then definitely.
So they are usually platinum
anode,
or
and then what will
graphite.
discharge? The Cl minus will discharge. However, okay, if it is not concentrated, we ask, are there halides? If there are no halides, then OH minus is gonna form. And if it is not concentrated and there are halides, then again OH minus is gonna form. So let me write another table. I will open a new page. I think it's gonna be better. So we have SO4 2 minus, NO3 2 minus, OH minus, Cl minus, Br minus, and I minus. So what's gonna happen here is that first thing we're gonna do, we're gonna see concentrated or not. So first thing we're gonna check, is it concentrated or is it not concentrated? So let's say it is concentrated. If it is concentrated, if we're dealing with OH minus, then OH minus is gonna discharge. If we're dealing with Cl minus, then Cl minus is gonna discharge. If we're dealing with Br minus, it's gonna discharge, and then I minus also is gonna discharge. However, if it is concentrated and we are dealing with NO3 2 minus and SO4 2 minus, they're not gonna discharge. Instead, OH minus is gonna discharge. However, if we are dealing with not concentrated, okay, then the only thing that's gonna form is OH minus. So directly, you look at it, you see not concentrated, we know the only thing that's gonna form is OH minus. So again, I'm gonna repeat the cathode rules and then the anode rules. So in the cathode rules, either metal or hydrogen discharges. Now following this rule, we know that Na plus, Mg2 plus, Al3 plus, and Zn2 plus do not discharge. Instead, H plus discharges, okay? And then Cu2 plus and Ag plus discharge as themselves. Then moving on to the anode, we have to ask two questions. First question, is it a halide and is it concentrated? That's the second question. So let's say it is concentrated. If it is concentrated, then I minus will release itself, Br minus will release itself, Cl minus will release itself, OH minus will release itself. However, SO4 2 minus will release OH minus, and O3 2 minus will release OH minus. Now, if it's not concentrated, the only thing that is gonna be released is OH minus. So now we move on to something called electroplating. We write it like this. Now, what exactly does electroplating mean? Well, very simply, it means that we use electricity to layer a metal or to layer an object. okay? So for example, spoons, you see the golden spoons at some stores, these are plated, or like, you know, some necklaces that are plated with gold or plated with silver. This is done by something called electroplating. So they use using electricity to cover an object with a thin layer of metal. Now, why do they do electroplating? For many reasons. Maybe for the material to look better, for less corrosion to happen, and etc. Like many other reasons. Now, to electroplate something, the metal to be used is either Cu or Ag or Ni. Cu is copper, Ag is silver, and Ni is nickel. Now, how does electroplating actually work? We have the object to be plated on the cathode. So let us take an example. Let us draw again an electrolyte. Okay, back here. Now the object to be plated is placed at the cathode, which is the negative side. So let's say we are plating a spoon. Okay, this is a spoon. It is placed on the cathode, which is the negative side. And then the method to plate with, let us say it is nickel. We're gonna plate the spoon with nickel. It is placed at the anode. So then this is the battery, positive, negative connected. And then the solution, okay, has to be nickel. The electrolyte solution has to be nickel. So the object to be plated is placed on the cathode, the metal to plate with is placed on the anode, and both of the objects are dipped into the electrolyte solution of the metal of the anode. So now what happens is that the electrons of the nickel, they will move, and they will come here to this spoon, okay? It becomes negatively charged, this becomes positively charged. And so then the nickel, which is usually a metal, okay, it will be attracted to the spoon and it will form a metallic layer on it. So this is pretty much it for today. Thank you guys for watching, and I hope you have a wonderful vacation and a wonderful back to school.